Today we are going to study about determinants. First, we'll learn what is determinants. Determinants are the scalar quantities obtained by the sum of products of the elements of a square matrix and the cofactors according to a prescribed rule. In mathematics, the determinant is a scalar value that is a certain function of the entries of a square matrix. The determinant of a matrix A is commonly denoted by det A or modulus A. Its value characterizes some properties of the matrix and the linear map represented on a given basis by the matrix. Between matrix and determinants. A matrix. In a matrix, the set of numbers are arranged by two rectangular brackets. In a determinant, the set of numbers are covered by two bars or by a modulus sign. In a matrix, they can have number of columns and rows, but in a determinant, the number of rows and columns is always same. And in a matrix is an array of elements that is denoted by n. A determinant is a unique number related to that matrix. Now, applications of determinants. First, graphic designing. The determinants are used in graphic design to make digital images. Determinants are organized in rows or columns. In graphic designing, they are organized into row pixels or column pixels. The numerical value is the pixel color codes of the image, video, etc. Additionally, determinants can also give results in the pattern of a graph. Second, civil engineering. Civil engineers use determinants in the construction sector. As we have seen, a building contains a linear structure. Before making a building structure, the architects create a map or design of the building, and in that map they make sections for the different areas. So the divisions of the sites is also a part of applications of determinants. The third application is business and economics. The graph is the best example of the application of determinants. Using graph, one can easily assume the trend of business and the status of its shares in the share market. A graph representation of the data helps find information about the stock market. The fourth application of determinants is geology. Geologists apply determinants and matrices for taking seismic surveys. Through this, they can measure the wavelength and pressure of seismic waves.
The next is robotics. In robotics, matrices and determinants are used to represent the position and orientation of robots and their end effectors. They are used to calculate the kinematics and dynamics of robot arms and to plan their trajectories. Next is quantum mechanics. Particularly in the field of quantum mechanics, matrices and determinants are used to describe the states of a particle. A branch known as matrix mechanics, which uses matrices as state and operators, was one of the first two mathematical formulas along with wave mechanics that gave way to the development of quantum mechanics. Next is in cryptography. For determinant cryptography, a message is converted to numbers and broken into vectors, which are then encoded by multiplying with an encoding matrix. The encoded message is transmitted and decoded by the receiver by multiplying the vectors with the inverse decoding matrix. Next we have mathematicians and their contributions. First, Gabriel Cramer. In 1750, he published Cramer's rule. It is one of the important methods applied to solve a system of equations. In this method, the values of the variables in the system are to be calculated using the determinants of matrices. Thus, Cramer's rule is also known as the determinant method. Next, Austin Louis Cauchy. It was Cauchy in 1812 who used determinant in its modern sense. Cauchy's work is the most complete of early works on determinants. He proved the earlier results and gave new results of his own on minors and adjoints. Thank you.